Hi Year 10, nice to see you. You have to guess what's in my box. And I've watched a YouTube clip about how to make a good clip, and you've got to keep something for the very end. So at the end we'll have a guess, see what's in my box. Right, today's lesson we're having a new topic. Have to pop the title, the particle model, and it's the whatever of May it is that you happen to be doing this on, and draw yourself 3 lovely boxes. Now you have to push pause and think about filling those boxes up with whatever sort of particles you are for the states of matter. So push pause and do that now and add all the other bits. Oh no, there's somebody trying to escape out of my box. Lobster! Can't escape out of my box. I might need some help. Ugh. Right, brilliant. Put as much detail on as you can. I've also sent you a PowerPoint that looks like this. So it's got a YouTube clip with what you want to... So clip on the YouTube clip and watch that, and you can add more detail to your very nice particle model. Hopefully yours now looks like mine. And you've got a box for your gas, a box for your liquid, and a box for your solid. Ooh, who had a really good go at my dingbat? Shall I tell you right at the end? So submarine, a lime, an 8, and a shun. It's for one of the arrows on there. And your task for this week, your challenge is to find a dingbat for the opposite of whatever that is. Okay? So I've got my 3 states of matter, and you have to add in melting and boiling, condensing, evaporating. Your dingbats go both ways. As the temperature increases, the energy of the particles increases too. So they vibrate on the spot at the bottom, then they can flow as a liquid. In your liquid, you can do this at home. If you've got a bottle, plastic squidgy bottle, almost completely full of water, just nearly have a little bit. Oh no! Ah! Oh, my handy helper has escaped. It was a fluffy rabbit in the box, and he wanted to meet you all. So there's Fluffy the rabbit. Sorry, Fluffy. He did want to meet you all. Here's my Fun Physics Friday helper, Fluffy the rabbit. So it's going to help with our kinetic theory, obviously. He's made of solid liquids and gases, and he didn't fill up my box. So he's going to help because he's just lovely. So you've got something a bit like this, hopefully. And then we've got to talk about the difference between chemical and physical changes, so you can make some notes about those. And he eats his food, and he makes poo, which is definitely a chemical change. Although rabbits are funny, because they have to eat their poo twice to get the proper chemical change, to get all of the nutrients out of their food. That's really good. And then we're going to link kinetic theory and temperature. Now, as you know, Fluffy maintains his body temperature because he's a mammal, and the energy transferred in is equal to the energy coming out. There he is. Look, you say hello, Fluffy? Hi. And in your physics last test, the energy balance needs to be the same to maintain a constant temperature. So you do it, and I do it, and the rabbits both do it to maintain their constant temperature. So there's a link between, I'll just pop him down, kinetic theory and the temperature. But you need to be really good at changing the temperature into kelvins. So you need a new title, kinetic theory, and you need a graph, a line graph that looks like this. I've got absolute 0 at this end here, where the particles have got no kinetic energy, going up there in kelvins, and then I've got the mean kinetic energy of particles coming up here. Now there's a really good YouTube clip on the PowerPoint I've sent you. Now this, if I can turn this round, I'll be better at this next time, I promise. It's not going to work. On there, you've got a graph of temperature change and what happens when they change the state and the temperature changes. So on here, the temperature in kelvins is directly proportional to the kinetic energy of the particles. Now you need to be really good at changing, he's now eating my shoelaces, your kinetic energy into, from kelvins to Celsius. Some of you should know how to do this. At absolute 0, it's minus 273 degrees centigrade. So that's minus 273. As we go along and get to 273 kelvins, hopefully you'll realise it's 0 degrees centigrade. So you can think about what's going to go in that box there and how you change your kelvins to degrees centigrade. On the YouTube clip that's provided in the PowerPoint, there's 2 ways of doing that. The last YouTube clip, I've looked at both of them today and they're really good. Goes on about the Boltzmann's constant, which you don't have to be able to do for your GCSE, but if you're interested in physics, I think it's fascinating. So does Fluffy. So have a watch and you can see what you might have to do if you're doing your A-level physics. I will try and do a better clip to introduce whatever topic we're doing next week. If you can work through the PowerPoint, draw your diagrams and make some notes, I'll put some questions up for you and some other things to do. It's lovely to see you all. Fluffy was very pleased to meet you. Bye.